Hey everyone, thank you for checking out another video. It's been a while since I did a generative art tutorial, but I've been working on this cool thing directly and immensely inspired by the work of Piet Mondrian, and I just wanted to share the code. I'm not going to start with a blank file and kind of walk through every line just because, I don't know, it's a very short program and I feel like maybe it's better if I just kind of talk about the different pieces of it, and then you can look at the repository, you can grab the code, and you can play with it on your own. If this is your first introduction to the idea of generative art, I can explain it to you really quickly. It's this idea that we use code with a mixture of rules and randomness so that we can define a system in which we kind of have control, but the result surprises us. So I've defined this system, this program that creates these Mondrian style grids based on his color palette. And if I run the program again, then we get a different result every time. And then as I start to play with some of the hard-coded parameters, the program just reacts differently and we get different images. So that's the idea behind generative art. You can make some really cool things and you can focus on all the fun mathematics behind it and the color design, and it's just a wonderful hobby. So I started with just some basic images of Piet Mondrian and I tried to kind of recreate those, and then I worked from there and I kind of built out this thing that would allow me to add a little bit of my own style where the grids are separated. They have some separation between them rather than just the outlined rectangles in his compositions. I can change a couple values and you will see more of kind of his style. So this would be a little bit closer to kind of what he did, where there's no separation between the individual grid cells. There's just this thick line between the colors. And then, of course, his was much larger rectangles. That's because of how some of my things are aligned. So maybe that would be a little closer. Not even that. Maybe something like this. Uh, Maybe that's getting a little bit closer to kind of his style with much larger regions rather than the very small things that I was working with. So that's kind of what I started with, and then I just kind of built from there. So I'll walk through the code. Again, there'll be a link in the description to the GitHub repository. If you don't want to listen to me talk, you can just go there and grab the code yourself. This is done in processing. So processing is an application that allows you to very easily use vector graphics through various languages. The primary one is usually Java or JavaScript. Right now I'm actually using a Python module for it, and I think it's built off of something called, it's still some type of Java. I'm not exactly sure how it works, but we're writing in Python code, but it's 2.7 syntax, I believe. So some people get upset that it's not pure Python, but this is definitely doable in pure Python. You can go through all the hassle of downloading or setting up a virtual environment and using PyCairo and all these different things, or you can just use processing and make things a lot easier. So if you want to run this code specifically, you will need processing and the Python module, which is very easy to set up. So what I started with is figuring out a way to subdivide large rectangles. So if I let me drop this to 0 and just see what happens. So let's say I start with this large rectangle, and I've just defined this in its original form like this. So this is maybe it isn't the best to just kind of walk through this code one piece at a time, but I thought it might be kind of cool. So I start with this quads list. The first thing I do is I append another list to it that kind of contains the corners for this first rectangle. I've defined this edge variable as 10. So just imagine the edge is the top left corner of the rectangle. So right here would be 10, 10. And then we have width minus edge for the right corners. So this would be the top right corner, the bottom right corner, and the bottom left corner. So we're just defining it based off of the width, the height, and this edge value. That way if I change the height, let's say I change the height to 300, now I still have the same rectangle with the distance from the edges of the canvas itself, but everything adjusts on that original quad. And I just call it quads, but they're really just rectangles. So this idea of subdivision, what I want to do in order to create this Mondrian shape is take a rectangle and I want to split it either horizontally or vertically and then create two new rectangles. So the basic idea is that we're going to take a rectangle and use some mathematics behind its edges to split it, remove that quad or rectangle from the list, and then append the two new ones based on the new corners. So you can see a lot of that happening. The first thing I do when I'm stepping through is I grab a random quad from the list, and then I get all of its corners. So I say, well, I get all of its position variables that I need. So this is like quad, left X, right X, top Y, and bottom Y. And I just grab those from the list based on this Q index. Then we're going to use this. Let's ignore this splits thing for just a second. This random if else is basically just saying it's either going to be horizontal or vertical. So if it's this, then this would be where it's splitting vertically, because we're taking the x values and we're going to define an x split. So we take the right x, which would be the larger value, and we take the left x, which is the smaller value. We divide it by 2 to get the just the midpoint between them, or kind of the mid. We get the size of the rectangle and then divided by 2, essentially, the width of the rectangle. And then we would multiply that by some split value, and I'll explain that in just a second. And then we just add that to the left x. So the split values are kind of how I've started defining where the lines will go. So let's break this down to 1. Let me run this. We've got this original rectangle. If I bump the subdivisions up to 1, then we're going to split only once, and it's either going to be, randomly horizontal or randomly vertical. But where that split is happening is based on this. So I've grabbed this midpoint, or mid-length, or whatever you want to call it, between the original rectangle, and that's where the split happens. But if I change the split value to 0.3, now it's going to be somewhere else. It's going to be like 30% instead of dead in the center. Well, technically, I guess it's 30% of the half. But the way that this works is I'm just grabbing a random value from this list, and I'm using that to adjust the value of the split. So that's how this split is coming into play. I'm using that just to adjust this midpoint. After that, all you have to do is I just pop the quad off the list, and then I add the new ones, and we're just doing some math where we say, okay, so this is the new, if we were splitting vertically, then this would be the new left quad. So the quad left x stays the same, quad top y stays the same. But then on the right side, we want to work off of this x split, and then the same thing for the bottom right corner, and then the bottom left corner is the same. Then this second line is adding the right rectangle or right quad, and we start with the x split because this would be referencing the top left corner of the quad, and then this one over here would be referencing the bottom left corner. So that's the general idea of the subdivision. We're just splitting, we're creating 2 new rectangles. This sep value is how I'm creating the separation between the individual rectangles. So right now I've got the sep at 1. If I drop this down and I show you again, it's very slight, but you can see it kind of there. If I bump this up to 3, then there'll be a little bit more of a split, and then I can obviously bump this up pretty high. We'll say like 20, and now they're very split. And that looks okay when it's like that, but if I bump the number of subdivisions back up a little bit, so that doesn't look wonderful, but it would look a lot better if the subdivision was higher and the separation is lower. So what if we said 2 and then subdivisions 500? So now we're seeing how that separation just has kind of a cool effect. You could go either way. So that's the idea behind the subdivision. I have these checks in place to make sure. So I've got these, like, if the right x and the left x is greater than min diff. So I define this min diff value just to say that I don't want to start subdividing any quads or rectangles that are way too small one way or the other. Even if I set a min diff of 15, it already completely changes the outcome of the image just because we're not subdividing anything that's obscenely small. If I set it to 30, and then I set the separation down a little bit more, now we're back to kind of the images that I think look really good. So that's that. That's what I want to talk about. And then the last part of it is just going through and drawing everything. So I set the stroke color to black, and the stroke weight's very small at 1. And then I just step through everything. So for Q in quads, we're grabbing one of these lists of essentially corners. I'm grabbing a random color from my colors list, which, like I said, I just basically pulled this from one of Piet Mondrian's compositions. I just use a random color picker, and then I use this begin shape, end shape to just add vertices and draw the rectangle. So very simple. It just steps through every list of corners, steps through every corner and adds it as a vertex to the shape, and then it closes itself with that close tag. Okay, so I think that's pretty much it. I don't know. I don't know if this is a good format. You'll have to let me know in the comments. I always feel weird when, it's a very short program and then I kind of start from scratch and I walk through every line of code, and I feel like it takes a little bit longer. So I thought it might be nice if I just kind of stepped through and talked about the code that already exists, just in case people wanted a little bit more clarification if looking at the GitHub isn't helpful enough. I'll probably clean this code up a little bit, maybe add some comments before I create the repository, so it might look a little bit different when you look at it, but all the logic will be exactly the same, and hopefully this is helpful or interesting, and maybe you'll see an opportunity to make something of your own based off of this. I give all the credit to Piet Mondrian, obviously, wonderful artist, and directly inspired this project, which was a lot of fun to work on. So thank you for watching the video. If you enjoyed it or learned something new, remember to hit the subscribe button, and hopefully I'll see you in the next one.